at the end of it, if people have questions, I'll be happy to take them up. So I believe it could be the question is this, which would be of much more value. So I'm very open to take up questions, even if I don't know about something. I'm always happy to get back on it. So the way I've structured this discussion is initially talk about what is blockchain, define it, and also try to address some of the misconceptions around it. Then talk about technology itself a little bit. Then talk about various applications that's possible. So that is where I will talk about the opportunities in there. Then I will touch upon the regulations a little bit, where how the various countries are attempting to regulate. I'll talk about that, and finally in this challenges, I'll also talk about various scenarios that has pop up in the past, which just created challenges. So this is how I've structured it, and no, I'm not very sure about the type of the audience. So some of this may be a little too technical. I'll try to keep things as simple as possible. So let me start with this slide. So this is generally how a blockchain ecosystem looks like a mix of multiple blockchains and how they interact. So at the bottom level, we have what we call as block prediction consensus, the databases, etc. Then on top of that, we have the logic or the where the what we call as smart contracts and similar logic resides there. And then at the topmost, where I've written as D apps, that is where typically most of the applications that end users interact with lives. So it's a pretty massive system, and each of these boxes that we see here, it generally requires its own sessions. So it is just to show that it's a complex architecture, and that also gives the challenges, and also it's pretty beautiful because it all works pretty seamlessly. Okay. So personally, when I have I received this blockchain or Bitcoin dot PDF, a PDF document, I believe around 2011. A friend had shared it to me. I tried to read it. Honestly, I didn't understand much. Um, so one of my biggest confusions in approaching this idea of Bitcoin was that I thought it's a new technology or some technology, and I had to read it, and I didn't understand much. Then later, maybe 4 or 5 years later, I realized that it's essentially not it's not like a new technology as such. It's primarily economics. And personally, coming from an engineering background, I had no clue what economics is. I still don't have much, but I try to mug up a little bit. So that was the biggest misconception I had, and even right now, I think many people try to look into uh, blockchain in general. When I say blockchain, public blockchains, as if it's a new technology or just money, but it's a lot more beyond that. Generally, the primary public blockchains like Bitcoin, Ethereum, etc. What they try to do is they're trying to mimic central banks. For example, in India we have RBI. So how these blockchains, the primary objective is to mimic these central banks, and then they are minting money. And unlike many of the central banks, which keeps on printing money, there are strict rules on how to print money. For example, we in generally countries try to keep gold bullion, and then uh, they try to print the money so that the supply is limited and the money has value. Uh, But around 60 years back, we have given up the gold standard, and now we have something called as fractional reserve. So the value of the money is often questionable. So that is the primary aspect which has been addressed in blockchains like Bitcoin, where the value of these currencies, which the chain mints, it is regulated, it is strictly controlled, and again, it's deflection. It is not an inflation-driven system. As time passes, the amount of coins or the money that is created goes down, which means the system remains like a non. It doesn't allow to have inflation. So these are some of the core ideas that we need to understand if you want to understand more about blockchain. So economics, it's an economic invention. Then moving on to some of the core technologies that used. I won't get too deep into it, but in general, blockchains uses two technologies by the name hashing and cryptography. So hashing is in general what we do in hashing is I've shown a screenshot here. So what happens is you have text which is one to around 6 lines long, and hashing is a mechanism where you give a text, a large amount of text. The hashed result will be a small result. It always gives a deterministic and smaller output. For example, for this dummy text, which is around 6 to 7 lines, we have a very small one-line text. So this is generally what hashing is. If there are people from BTech, I'm told that there are people from BTech, students from BTech background here. Uh, you might have studied about this in detail. But roughly, this is what block hashing does. You take a large text and generate a smaller text, and it's always deterministic. So in the industry, we use it for let's say for tracking the integrity of files and things like that. Even for when we send a message from one location to another, some form of hashing or CRC is used. Now, in Bitcoin, which is the first blockchain, which was created around 2008, we it's what we've been used as that we are using SHA-256, and Ethereum uses similarly slightly different one, which is SHA-3 equivalent. But end of the day, these are pretty similar. Another technology that is widely used, or the foundation, is the public key cryptography. Public key cryptography is a type of, let's say, hiding secrets using two different types of keys. So we also call it as asymmetric key cryptography. So one key it will be two parts, like a key to a locker. One key will be private and or a secret, and another one will be public. So I won't get into the nitty-gritty details of which algorithms are used, etc. But these two technologies forms foundations of every blockchain, every flavor of blockchain out there. Now, we also have to take the roots of where it all came from. So before the blockchain was introduced in 2008, the first blockchain was Bitcoin. There were also other attempts of creating digital cash. Way back in '97, there was a paper and a project which created something called as uh, I think it's called hash cash. Again, that was also used based on hashing that we mentioned here. Then there was another attempt. Probably it does not having an implementation, but it is called uh, I think it's day. It's called B money. Again, again in these cases, the idea was that instead of using physical printed money and bank accounts and all, we can use electronic means to represent money. And Hashcash was primarily used in tracking or preventing spam emails and such, so that any I've mentioned, as I mentioned in this slide, hashing anything that is using hashing, it requires a lot of computation. So the idea is that for every email that has been sent, you include hash, and you cannot send large amounts of emails because every small email will require high computation. So these attempts were there prior to 2000. Then in 2008, we have the Bitcoin was introduced by somebody with a pseudonym, which is Satoshi, which is now pretty popular, and it's like a myth now. So either a person or a group of people, arguably with lots of background in economics and mathematics, created Bitcoin as a technology, and this used a lot of ideas that that we had earlier, like all this Hashcash and B money. Similar ideas were used, but what has dramatically changed is just those technologies were like centralized. You need a central issuer like and a client server architecture, which I'll get into a little later. But Bitcoin introduced something that we call as peer-to-peer network, which is very similar to uh, what we have in, let's say, all these torrent-based systems. Like pretty much every torrent-based systems has this peer-to-peer behavior. So that is one of the biggest differences what we have in Bitcoin compared to, let's say, something like Hashcash or B money. Another idea is that an idea called a public transaction ledger is created. Uh, we'll talk about that also in slight more detail later. But generally, what it means is every transaction that end users perform, it is visible on a public ledger. So these were the main changes that were brought in. And then earlier I talked about how the currency issuance is regulated. So the Bitcoin also introduced very strict and unchangeable rules regarding how the currency is issued. And to coordinate all these, there was an algorithm called proof of work, which enables all these nodes on the decentralized network to create nodes and blocks and then achieve consensus. So these are some of the core ideas which was introduced in the Bitcoin, and it is this idea of public ledger and a combination of how hashing and public key cryptography was introduced, and how economics is applied in a very beautiful uh, real world application. That is the academic pedigree of Bitcoin. Now, beyond Bitcoin, later we have lots of new other blockchains as well. We have the most predominant ones like Ethereum, and there are numerous others as well. But these ideas like the decentralized peer-to-peer network, the transaction ledger, etc., which was introduced in the Bitcoin, that largely remains the same. So I'll also talk about the architecture, which is one of the primary ideas that we talked about here, the decentralized peer-to-peer network. So traditionally, when the computing entered a stage where systems started getting networked, we introduced this idea of client and server. Very simply, you have a web browser and it talks to a backend application. Normally, will be a certain servers where logic will be executed and data on a database. So typically, this is a client server architecture. Now, what is different in the case of Bitcoin or any of these torrent like networks is that there are a bunch of peers and they'll be talking to each other. And unlike a client and server, where server is the authority or a master of data and ownership, there is no one single entity covering everything. So there is a very fundamental difference between the traditional architecture and what we have in a public blockchain. Then we talked about a public ledger. So this public ledger is where we have all the transactions being created on a publicly visible book, let's a book or a ledger, which anybody can access. So if there is anybody with background in accounting, commerce, they would know this idea of debit and credit. So this is very similar to that. So there is the idea of double entry accounting, where debit is anything that goes out and credit is that what something that comes in. So this same similar idea is used in the Bitcoin or any blockchain as well. They're naming it as slightly different manner. But as I've shown in this right side table, essentially what it does is any debit that comes into Alice and Bob, one person's account, that is entered, and any credit is also entered. And finally, this must add up. This is like a fundamental principle in any accounting. And the same idea is used here, albeit with different terminology. And unlike a personal accounting book, let's say we maintain in companies, etc., everything is public. So anybody can track these transactions. So this is the another innovation that has been introduced in the case of Bitcoins. And the previous ambiguous transactions, it looks something like this in reality. I've taken a screenshot of some transactions I could find. So here we can see that this left side address, this BC1, that is one of the Bitcoin addresses. And we can see two amounts of transactions, which is uh, going out of the account. These are debits. And here, this green arrow shows these are credits. So this is how typically an address looks like, and this is how typically transactions also looks like. Now, again, another point I talked about was the currency issuance and consensus. So what happens is in a typical real world situation, like let's say INR or dollars, the banks will be printing based on when I say banks, RBI or the whomsoever as the central bank, they will be printing based on the market demands and whatever internal criteria they have, and it is not fixed. I mean, it keeps on changing based on scenarios, and inflation means mostly more currencies printed out. So it is not something that we have created. Let's say, let's say RBA was created in early uh, in the previous century, but nobody has created let's say rules which doesn't change. These rules keeps on changing. But when it comes to something like Bitcoin, these rules are fixed, and it cannot be changed at all. This is a very fundamental difference, and arguably this makes sure that these currency which is created, it has a value. The value doesn't diminish or inflate over a period of time. So generally, what happens is we have this idea about blocks, which I will come to a little later. So what happens is whenever 210K blocks, which is 2 lakh 10,000 blocks, the number of currencies issued halves. So it started with 50 BTC or Bitcoin per block, and it is capped at 21 million. And every time we have approximately 2 lakh blocks, this per block reward or the new currency that is printed, it reduces. So it become like 12.5, and right now it is 6.25. And you cannot print infinitely many bitcoins, which means even if there is a lot of demand or inflation, we cannot increase the number. It is capped at 21 million. That means sometime in 2040 or so, we won't be able to print any more bitcoins. This sounds pretty much like any of these rare earth metals like gold or other platinum or those kind of metals where the supply is limited. So it is not like an infinite supply. We can keep on printing currency. It's limited at a predefined number. Then we talked about how does all these decentralized nodes. We talked about having numerous nodes in the network. There is no client and server. There is nobody with a centralized command or authority like in a client server architecture. We have this peer to peer. Now, how do they uh, reach consensus? How do they create new currency? So this is defined by the proof of work algorithm. And this slide hopefully also explains why we're calling this as a blockchain. So these algorithms they create what we try to grow as a blocks. So we have like a block like data structure with a block header and various other parameters inside it. So we typically depict it as a box. And let's say we have block number one and block number two. So these blocks are connected, and it creates a chain like structure at the end. So in a three-dimensional space, it will look like a like large number of blocks connect linked to each other, and the linking happens through the block numbers. Every new box or every new box or a block that we add to the network, it will be referring to the previous blocks number. And apart from that, there are a few other parameters as well. So it is like a chain. You have a chain of blocks. So that's the reason why we're calling this as a blockchain. And what happens is every time we need to create a new block, it is like solving a puzzle. Like maybe it is as simple as we can think of it as something like finding the next odd number after a very big number or a prime number. In the case of blockchains like Bitcoin, what happens is again, it's about finding a certain number which is smaller than hash value. That and we call that as a difficulty target. So it's always about finding a certain number represented in a SHA of 256 format, which is smaller than a certain number. So that's how the this chain works. And every 10 minutes, roughly every 10 minutes, we find a new block. So I'm not getting too much into this because it could be pretty complex to explain. Simply put, we identify a new number every 10 minutes based on numerous conditions. And if anybody who finds these new number, uh, they will be rewarded with, let's say, 6.25 Bitcoins. So, and this is an ongoing process or like a treasure hunt with a predefined set of rules. And again, in this, again we have hashing being used here. It's an application of SHA-256 hashing in the case of in bitcoins. So what happens is every time whenever somebody finds a new block, that person is called as a miner, and that mining, just like mining gold or any of gold or iron mining or any of these type of mining, and like mining, and uh, they're given a certain amount of reward. And apart from these, the mining, there can be other type of transactions also, like some person A sending funds to person B. That part of those funds are also given away to the miners. And so this chain is formed, and this particular chain is what, uh, first of all, introduces new coins and also keeps the network running. I'll stop it there. If you have questions, we can discuss it at the end of it. Now, I'm moving on to the this idea about cryptocurrency. So we talked about finding these unique numbers, and people are getting people are rewarded every time this unique number is created. So this reward is what is termed as the cryptocurrency. And the reasoning is pretty simple. It uses both cryptography and hashing extensively. So we call this process as an um, the process of creating this reward as mining, and the result, these numerical values like 6.25 Bitcoin, which is issued right now for finding a new block. Uh, as this process is mining, and these values as cryptocurrency. And typically in these blockchains like Ethereum or Bitcoin, we have this idea of native coins. So Bitcoin or BTC is the native coin for the Bitcoin network. ETH is for Ethereum, SOL for Solana, DOT for Polkadot, and so forth. So native coins are always created for by mining, and beyond the native tokens, we also have non-native tokens. Like for example, Ethereum, you can have any number of new coins to be uh, created. And the fundamental difference between these native and non-native coins is that native coins are always created by mining, and the others are created by uh, programs, what we call as smart contracts. So I'll talk about it. So yeah, so I was mentioning, I was talking about these non-native tokens. So they are created by the what we call as smart contracts. These are programs which are residing on the blockchain. And again, I think I talked about this already. And yeah, another point which I think we should talk about is that anything that is being entered into the ledger or the record on the blockchain, that is immutable, which means typically in a database, any of these applications, once you have something in that database, it's possible to edit it. But in the case of blockchains, for any blockchain, the data that is once entered into the chain, it is always immutable. And this immutability is a parameter which we can use for various purposes, which we'll touch upon a little later. Then we talked about smart contracts, especially in the context of these non-native coins. Now, what are smart contracts? So smart contracts are uh, programs which or logic which end users can write, and it can be submitted onto the blockchains. And once we have these programs on the blockchain, we can pay the network to perform the computations. So it is very similar to, let's say, cloud computing, where you get hardware and execute your programs on that. But albeit, smart contracts will be a lot more, very smaller, and Ethereum blockchain, they are the first to introduce smart contracts. The idea is that we already talked about various rules and mining and everything. So computation was already being used. So let's say one of the primary innovations in Ethereum is that they extended it a little bit, and rather than focusing on pre-defined logic, they also started executing new programs. So, and then for running new programs, the chain or the platform started charging people. So that's how the smart contracts got introduced. And the difference between a smart contract or any other program is that you have the smart contract living on the blockchain, and every time somebody executes it or invokes it, it gets invoked on all the nodes across the network. And on this slide, I have created a quick workflow on how to create the smart contracts. I think I won't get into the nitty-gritty details of it. And in very simple terms, what happens is every node will have a virtualized environment, and these special programs that we call as smart contracts, they will be running inside inside these virtualized environments. And in the case of Ethereum, we call these as EVM or Ethereum virtual machine. I've also shown a sample. So this sample is from a real world application. So what's happening is a certain data is stored onto the blockchain in an immutable manner, and it is used. It can be used for auditing the later point in time. Now, this is where things gets a lot more interesting. How we can use blockchain for uh, securing things. How can we issue, let's say, certificates and things like that. So there are like numerous applications of smart contracts, and in all these cases, what we are using is, first of all, the whole ecosystem is decentralized. Means there is no, it is not possible to censor them or stop these from being executed by any manner. Then it becomes transparent and immutable. And finally, we have a global system. And end of the day, all these smart contracts will be acting against money. So that gives us something that we call as programmable money. And these facilities gives rise to numerous applications, starting from financial applications, having contracts being on the chain, having a supply chain, a traceable supply chain. Maybe another idea is in the context of chain of custody, we can have chain of custody in a forensic investigation being handled with the blockchains, etc., etc. So all these numerous applications are are deriving out of smart contracts. And they're also trustless, meaning you don't need a central entity or a certain computer to be owned by you or me. Uh, the smart contracts has introduced a new way of using any computer, and still we can trust the result of it. So, in general, the application of blockchains are including it includes smart contracts in some way or another. Now, these are some of the applications of smart contracts. Like we can create digital certificates, and one example that I've come across is in the supply chain scenario for an in the aircraft manufacturing. What they've done is for every spare part, even small screws or nuts and bolts and everything, they have unique numbers. So the manufacturer creates these, and these unique aspects are stored onto the blockchain. And when it reaches, let's say, Boeing or Airbus or whomsoever is whomsoever is assembling it, they can always verify the authenticity by comparing against the blockchain. So personally, I feel these kind of digital certificates are one of the best examples. And another example could be the land records that we all have. So these land records are stored in a registry somewhere, and then now it's getting like a lot more digitized and everything. But still, we keep hearing issues about documents being lost, missing, being manipulated, etc., etc. So representing the entirety of land records and title deeds, etc., and in an immutable manner, that could be another very good example of how we can use the. And even in the case of these smart contracts, sorry, digital certificates, what we're doing is we're writing a smart contract and asking the smart contract to represent the title deed on the blockchain. Then another very common example is secure handshakes. This is a primary use case in the case of uh, supply chain, like shipping. So where there are like numerous contracts are being executed, let's say in an export import kind of scenario. That's an situation where lots of handshakes are involved. Right now, we are using, let's say, digital certificates and such. Still lack the transparency, and it's not seamless because the interoperability between systems is we are not yet there. So these are some of the innovative applications where the chain blockchains can be used. And moving on, what we typically see is all these financial applications like DeFi, DEX or a decentralized exchange, which is very similar to, let's say, our Bombay Stock Exchange or NSE. But the difference is that, like a centralized system, the logic will be running on a blockchain. And again, escrow. This is another application which I'll touch upon a little more again. Uh, then yeah, securely store the assets. So so these smart contracts, what typically happens is we once we mint all these assets, how do you securely store them? Who can have access to it? Can multiple people agree upon accessing? These kind of ideas can also be implemented with smart contracts. One of the one example, so now I talked about this digital certificates, and I think I just understood from the beginning that the participants of this session, there you are being introduced, you given some sort of a participation certificate, I believe. Now, one of the ideas is that these participation certificates that you're getting, it can be represented on a blockchain. So let's say you will get an email saying that click here to get a certificate, but you will probably get a image or a PDF or something like that. 10 years from now, where is this certificates going to be? You like I was finding lot of these school competition, quiz competitions and whatnot, and I have like no idea where it is. These certificates which I've myself earned. But imagine if all these certificates were on a blockchain, like you have a unique ID which is linked with your, if you have a something like an Aadhaar, it is linked with your Aadhaar and it's all on a blockchain. So obviously it will have a unique number as well. Every certificate that you receive for courses like this, or maybe your first standard, fancy dress competition, you can still find it, and these will be non-transferable certificates assigned to each one of us. So this is one very good example of how these digital certificates can be used. And again, these same ideas are being used in something like, uh, let's say, Digi Yatra, for example. Even in those cases, what is happening is they're issuing certificates to us and then tying these certificates to additional parameters like Aadhaar and let's say biometric and things like that. And when you enter the airport, what's happening is they're looking at whether you have the certificate, and if you have the certificate, yes, you can be given access to the airport. Another idea is these escrows. So escrows are typically uh, a conditional payment. So let's say I complete a task, or I ship an item to, let's say, US, and based on the receipt of the item, payment is being received. So these kind of scenarios are handled with escrow, and it's a very, very simple use case which we can do with escrow. So this is another good example of where smart contracts can be used. And even from a security perspective, the advantage is that these type of escrow systems is very simple to execute, and it introduces security because and also avoids the complication because contractual violations and such. Uh, it will We can avoid these kind of situations if we have escrow associated with contracts. So you enter in a contract with somebody saying that you complete a certain task and only then you will be paid. And the money is in an escrow. So there are no payment delays, there are no such challenges, there is no lack of service delivery, etc., can be easily handled with escrow. Because DID or decentralized ID, this is another example of where smart contracts can be used. So identity, like for example, our other project, it's a wonderful example of how we are using identity. Now, the challenge with this identity, as we know, is that it is stored centrally, and for any systems to use it, we have to interact with it. And as more and more systems start using it, the load on the central the other systems increases. Now, with something like DID, what's possible is you do the initial interaction with other, then the future interactions can be with your own system. So the European Union is implementing what they call as digital wallet. In that scenario, what they're doing is rather than creating a central system like other, they have a decentralized system. As I roughly touched upon, this DigiYatra is another example. So what in DigiYatra essentially what's happening is once you enter a handshake, you are issued an ID. It's called uh, credential attestation. You're attesting your credentials, your Aadhaar, your phone number, maybe your facial recognition, and a credential is issued to you. Now, if you have this credential, which is stored in your, let's say, your mobile phone, then you can be given access to the airport. So these kind of use cases are there and very secure and impossible to, let's say, break. So these are, I think, ideas like DID and this course certificates. These are some of the very good examples of how we can use the tech. And in the same core certificates idea. The similar idea can also be used with a slight modification for chain of custody in criminal investigations as well. Okay, so we talked about the tech, the opportunities, everything in a single breath. Now, at the same time, we also have to understand that because of the unique value proposition as an economic innovation, it introduces a lot of challenges also because at the core, it seems to be trying to replace the central banks. So that is if the governments and various governments have been trying to regulate the technology. And also another common myth is that it is used only by the cyber criminals. So we have all these challenges also and primarily because of this economic the attempt by all these cryptocurrencies to replace the central systems like rupee or US dollars, there's like a lot of regulations around this. So various countries have been trying to ask this question: Is this an asset or is this a security? Is this like something like a share? And another question was, is it a legal tender like a rupee or dollar? So most of the countries have answered that it's not a legal tender, except for I think one or two countries like El Salvador, I guess. Nobody has accepted it as a legal tender. And some of the advanced economies like US or European Union, they have been approaching they're trying to do the regulations, but these regulations it looks like different times, the different they end up giving different interpretations. In general, even though there is no clarity from bodies, regulatory bodies like SEC in the US, it looks like coins like BTC and ETH, they're not considered as security and European Union, they're sometimes they are considering as security. Sometimes they're even considering it as money. It's an ongoing uh, ongoing scenario in the European Union. And in India, we're not clearly regulating it, but there was a very heated case, a prominent case in 2018. And as a result of that, what has happened is RBI is not regulating it, they've kind of letting the transactions happening. But the tax department has come up and they have started collecting tax on the transactions. And generally, this is another interesting test that especially US, uses to define whether something is a investment or not. So generally, heavy test is used to define whether certain so if somebody comes up with an investment idea, whether that is security or not. So heavy test is something that has been used, and Bitcoin looks like, as per the heavy test, it's not a security, but everything else at least looks pretty uh, peculiar. Now, yeah. Now we also keep hearing lots of fraudulent activities because the tech is not exactly regulated. So we keep hearing a lot of investment schemes, including cryptocurrencies. Then we have what we call as exit scams, which is primarily from exchanges or projects. Then we have these unfortunate security breaches, starting from this one called Mount Gauss from 2011. Then even recently in India, we have m- major security incidents involving OCX in 2024 and CoinDCX very recently. And interestingly, from the news, I figured out this one called Morris Coin. That is a very uh, peculiar one. It happened very close to where I was staying during the COVID lockdowns. It's a pretty remote area, and it looks like even in that area these kind of scams were pretty rampant. And I will talk about various types of fraudulent schemes floating around. So some of these new generation fraudulent activities, they talk about investing fiat, and they offer high returns in crypto. Then all these work from home and easy money schemes involving students or housewives and pretty much everybody. Like a lot of such schemes, which again blends cryptocurrency in some manner or other. Then we have fake exchanges, NFTs, and memes and all. So, so in general, a lot of fake investment schemes are there. Another type is exit scams. So exit scam in a nutshell is somebody will raise large amounts of money saying that they will yeah. So yeah, exit scams is a scenario where people will offer something and then they will move away, walk away with the money. And other challenges is these exchanges. Exchanges is where people buy and sell cryptocurrency. There's FTS scam, for example, is an example where the customer funds were misused. Again, it's possible because of lack of regulations. Then we have security breaches. So these breaches are primarily hacking of some sort of other. It could be tampering with the smart contracts, which generally holds the funds, or the simple security lapses. So why do we have so many challenges? So my personal feeling is that the tech is fairly complex, and we approach it from a different angle. Uh, for example, at the beginning, I said it's not even a new tech; it's more of a an application, it's an applied economics and maths. And but we tend to look it as a tech, and we try to mix and match with what we know traditionally and end up having challenges. So these new specialized skills are required, which we may not have. And then across the globe, there are no uniform regulations. Even in the same country, if you take two different court orders, they one would say it is a security, and another one would say it will be mute on this part, but they might say, okay, you can probably collect the tax. So there's like a lot of confusion around that. So I think that's the reason why these challenges are happening. And so essentially, the tech is very powerful and it has been used in numerous cases. We can extend the use cases as well, but because of perhaps due to the complexity and lack of understanding, we keep having a lot of uh, challenges. And from here, I believe what we should do as practitioners of tech and law, etc., is that we should try to bring more clarity rather than limiting, explore the opportunities, try to understand what it is, and then try to use it. That's pretty much everything I had to share. I'm happy to take up questions if there is any.
Thank you so much, sir, for the thought provoking and insightful session. Your expertise has given us a clear picture of blockchain's potential, not just as a technology of the future, but as a present day solution to many of the challenges we face in cyberspace. Now, we would like to open the floor for the question and answer session. Participants, this is your chance to ask your questions directly to the Bobinson sir. Please type your queries in the chat box and we'll take them one by one.
So I'm looking at the questions here. So what governance challenges arise when blockchain networks cross international jurisdictions and cybersecurity use cases? Okay. Well, see, the primary challenge is that different. I think it was my concluding point also. Forget about different countries, even within the same country, US or even the European Union, there is no uniform opinion about it. People are still arguing, or different orders are still arguing: is it an asset? Is it money? Is it a replacement of something? So there's like a lot of confusions around what this is all about. Now, across the jurisdictions, so for example, if you take a country like US, where it is okay to pay with Bitcoin, but in India, it is not legal to, if somebody uh, selling tea or coffee, it's not a legal tender. You cannot buy and sell goods or services with Bitcoin. So there's a lot of confusions around this, and these confusions, when say for example, if something like a fraud or criminal investigation happens, it brings in a lot of challenges.
So
Now,
there's one more question. Can you please
okay.
suggest some authentic platforms to buy bitcoins and NFT and for creating certificates using blockchain technology?
So this is a pretty interesting question, because I think I would personally try to refrain from answering that question, because it sounds more like a financial advice, and I'm not supposed to give financial advice. See, I would say generally the Indian the exchanges that we have operating in India, the primary ones, without naming any, I think the primary ones are they're pretty safe, and they try to be uh, as much as regulated as possible. So I would say they're pretty much safe. But don't take advices from anybody, including myself. Do your own research and invest or buy. Okay. And for creating certificates and blockchain, okay, I don't think we have. I'm not come across like products which is offering this kind of creation of certificate kind of functionality. But if you look for Sol bound tokens, SOUL, Sol bound tokens on Ethereum, we'll be able to find more details about how to create certificates. Most of the time, what happens is these kind of requirements will be ad hoc, and people will be building it for internal users, or maybe like a session for this. People creates it and uses it, and not come across readily available products for that. Should blockchain based cyber defense systems be run by government, private consortium? Oh, sorry, I think I'm mixing up two questions. Sorry. Could blockchain help create a trust layer for the future metaverse or Web3, ensuring safe digital interactions? Yeah, so my answer is yes, and not limited to metaverse or Web3. If you what if Specifically the question about how to create secure transactions. So we are talking about having an identity, and creation of an identity is very much possible. Identity and secure handshakes. So this is one of the fundamental uh, features available with blockchains. And it doesn't need to be limited to all this metaverse or Web3 or anything. Even if you look at the European Union EU wallet project, which is a DID based project, that is an application of uh, this DID. So that is a very good example of how DID and the blockchain technology is used for creation of identity. So once you have the identity, you can use it anywhere. It need not be metaverse or Web3. You can use it maybe even on this particular call. Before joining on this call, everybody could have verified yourself with an ID. So that's very much possible. I see one more question from Shreya. Should blockchain should blockchain-based cyber defense systems be run by government, private consortia, or public communities? Well, the blockchain, very from a very uh, serious or very strict standpoint, the blockchains are supposed to be decentralized. That's the whole point about the blockchain. So it should be a combination of government, private companies, and public companies or public or private communities should be operating the blockchains. That would be the best approach, and then we can build solutions on top of that. But at the same time, you have public chains primarily I talked about public chains in this context. But if you want to, let's say, create some sort of an identity system only for, let's say, a college or an organization, you can also have private chains. So I wouldn't say it should be government controlled or private controlled. It should be a combination of both in any case.
Thank you so much, sir, patiently answering the questions. Now, as we come to the close of today's session, it's time to extend our heartfelt gratitude. First, a sincere thank you to our speaker, Mr. Bobinson, for taking the time to guide us through such a complex yet crucial subject. Your journey and insights have truly inspired us to think about the role of blockchain in creating a safer and more secure cyberspace. Next, a big thank you to all the participants for joining us today. Your presence and engagement make sessions like these impactful and worthwhile. Remember, awareness and knowledge are our strongest tools in today's fast changing digital world. We also extend our thanks to the organizing team working behind the scenes for making this session possible. Before we officially close, one last reminder, please fill out the post assessment form and feedback form that has been shared with you. It's mandatory for certification, but more importantly, your feedback helps us bring better sessions in the future. Once again, thank you all for being a part of today's webinar. Take care, stay safe, and let's keep building a cyberspace that's stronger, safer, and smarter with the help of blockchain. Thank you so much.
Thanks, everyone.
तो हम